Yes.
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 Okay, so as I was saying, we're very happy that Renaud could join us, and you'll get to meet him in a moment. Before we begin, a few quick things to go through. First of all, as you can tell, maybe now there's a big red button in the corner, and that means I'm recording this talk, and that will be making it publicly available tomorrow. Let's see if I can switch. Just a quick presentation of the Orbit team / GGG team present here today. We have Kasper, who is also on with the camera, but he'll say a few things in just a minute. He is Orbit Lab Commander. He's a professor at Aarhus School of Engineering, and he's also the organizer of the local Google Developer Group here in Aarhus. Yes. We have a two-part program tonight, a tech talk and a Q&A part. So the times in the program, they're an estimate, but we plan to finish around 6:15 in any case. So when Renaud starts his talk, I will ask all of you to turn off your cameras and we can turn them back on for the Q&A session. So if you have any questions during the talk, you can post them in the chat. But in order to avoid too much interruption, I think we'll save them for the Q&A part unless they're highly urgent. So you're welcome to post as we go along. And of course, we encourage you to follow Orbit Lab on the social media of your choice to keep up to speed with everything that's going on here. And if you like what we're doing, a way to support us is to engage with and hit like on our content. We would really appreciate that. So that's all that's left for me. And now I'll just hand you over to Kasper. And afterwards, we'll get ready for Renaud's talk. Over to you, Kasper.
All right. Welcome, everybody, to this. As Lida said in the beginning, this will be our last GDG Aarhus session / Orbit Lab online talk for this semester. But we will pick it up right after the summer holiday. And I'm extremely thrilled to have Renaud with us today. He was so kind to actually give us a custom-made talk. He had a really good idea, and then I said we have a lot of people in our community who love Firebase and already been working with it. So I think he will try and push us even further with some patterns, some do's and don'ts with Firebase cloud functions, which allows you to make serverless backends. But he will get into all of that. I just want to also welcome everybody who's joining from not our communities. I saw we have a participant from Ethiopia, which is really awesome. I think that's a new thing that we can start thinking about, is how we can have these global community events going forward. If you are interested in being part of organizing or helping out with doing some of these talks, making sure we get more cool content and great speakers. It's very easy to organize when it's online. You don't have to buy all the snacks and set up stuff. So we're looking for new organizers to join the team for Google Developer Group Aarhus. So please reach out through the Meetup group if you're interested in that. It's a lot of fun and you get to know a lot of cool people. So yeah, and without further ado, I'm going to pass it on to our speaker. And looking forward to hear what you have prepared for us.
Thank you very much, Kasper and Lita. So good afternoon, everyone. Good afternoon to you in Aarhus, but also to other participants from other places. First, I would like to thank the GDG Aarhus, and in particular Kasper and Lita, for giving me the opportunity to make a presentation on cloud functions today. I would like to really thank them for their very warm welcome. So it's the first time I use Zoom, so please be nice with me if I have problems to share my screen or to switch between the browser and the video. So now I will share my screen, and I will share the entire screen. And here, normally, you should see a presentation from Google Slides. Do you see it?
Yes, we do.
Okay, perfect. So the topic of today is cloud functions for Firebase, and in particular, what, when, how, and how not. Before diving into cloud functions, we will have a short introduction, a short presentation of what is Firebase and how cloud functions are positioned within Firebase. Give me the possibility, the opportunity to briefly introduce myself. So my name is Renaud Tarnec. I live in Belgium. I'm a Google Developer Expert for Firebase since February this year, and I'm a full stack web-based application developer, architect, and a project manager with more than 20 years of experience. I'm a freelance consultant, I have my own company, and my service offering is twofold. On one side, I do some web application development exclusively in Firebase, with single page applications or progressive web apps. And on the other hand, I do some interim project management, helping companies managing their web development projects. And so this second part is more with large companies like European international organizations here in Brussels or insurance companies, etc. I'm very active in the Firebase developers community, in particular on Stack Overflow, where I'm every day answering questions and helping the community. And I'm also active on Medium, where I publish some articles around Firebase. So what is Firebase? In a nutshell, Firebase is Google's mobile and web application development platform that helps you, developers, build, improve, and grow your app. Opla, sorry, the title is not the correct one. So it should be Firebase in detail. So it's a platform of 18 tools. Firebase is a platform of 18 tools that can support developers with web and mobile apps. Mobile meaning Android, iOS, but also Flutter today. We have three categories of tools with Firebase. We have developer tools like databases or file storage. We have also app quality tools like Crashlytics or performance monitoring. And we have business tools like Google Analytics or predictions. Personally, I focus on developer tools. And if we look here at this, the first column, you see that the developer tools category contains different kind of services. You have Cloud File Store, which is a real-time NoSQL database. You have MLKit, which is only for Android and iOS, which help developer, including machine learning capabilities. You have Cloud Functions, a mobile backend, serverless backend that we will look at into detail during this talk. You have a very, very good authentication service, which allows your users to log in with a username password, but also a lot of third-party authentication providers like Google, Apple, GitHub, Facebook, Twitter, etc. You have also a very good hosting service, which is somehow not very well known, but which takes advantage of Google's CDNs, and so it's very, very efficient. You have cloud storage, very important. It's where you can store and serve files and really heavy files to your users. And last but not least, you have a real-time database, which was the first database included in Firebase, and which is gradually replaced more or less by Cloud File Store. But there are still some very important use cases that must be covered by the real-time database and not with Cloud File Store. So in this talk, we will focus on the cloud functions. So Firebase, is it a serverless platform? So it's really important to understand that the Firebase services are hosted in the cloud. So it means that these products have backend components that are fully maintained and operated by Google in serverless mode. So for example, NoSQL databases, storage, file storage, infrastructure, and so on. But it is not, this is not all. Firebase also provides client SDKs, in particular for Android, iOS, Flutter, and JavaScript. And these SDKs allows you to interact with the Firebase backend services directly, in direct mode. So if you look at the right of the slide, on the top, you have the traditional web architecture, web application architecture, where you have a client tier, a client app, which will call a middle tier, your application servers, and those servers will interact with a backend tier with either a database or a file storage service. And you will have these three tiers, quite classical in the 90s and in the 2000s. With Firebase, there is no need to establish any middleware between your app and the services. You write your code directly into your app in order to interact with the serverless backend component in your app. So your app interacts with the backend components. And that's very important, and it brings a lot of advantages. In particular, it makes development much more faster, and this is something customers or people that pays for application development are very find very important, of course. So, like we said, Firebase not only provides database, storage service or authentication service, but it also provides a serverless event-driven backend, which is Cloud Functions. So what is Cloud Functions? Like I just said, it's a serverless event-driven backend. So Cloud Functions for Firebase will let you automatically run backend code in response to events triggered by Firebase services. It can be by different services, so by Firebase services, sorry, by HTTPS request, or by Google Cloud Scheduler. So we can separate those triggers in two main categories. On the one hand, we have the background triggers. So you will be able to trigger a Cloud Function if an event occurs with Firebase authentication, with Cloud File Store, with a real-time database, with cloud storage, with a remote config change, with an event with a Firebase Test Lab, with Google Analytics, or with Crashlytics. Okay, so those are the background triggers that are triggered by the services hosted in Firebase Google infrastructure. On the other hand, we have the possibility to directly trigger a Cloud Function. Here we have HTTPS request, so we can call a Cloud Function exactly like we will call the REST API endpoint, okay? But we also have the possibility to schedule Cloud Functions through the combination of Cloud PubSub topic and Google Cloud Scheduler. Okay, so in other words, if I come back to this slide here, you see we have the client apps, which interacts with the Firebase services, but it's not only from the client that you can execute some operation in these services. It is also possible from a backend perspective with Cloud Functions. So let's give some examples of background triggers. With Cloud File Store, the NoSQL database, you can trigger a Cloud Function at the level of documents. So just a small reminder, Cloud File Store is organized in document. A document is an entity that hold data items in the sense of fields, and those documents are organized in collections and sub-collections, okay? So you can trigger a Cloud Function each time there is a new document created, each time there is a document that is updated or a document that is deleted. And you see we have three different triggers, but those three different triggers are all united or all put together in an on-write trigger. So in Cloud File Store, the documents are the triggers to start a Cloud Function. Another example is authentication, the authentication service. So you can trigger a Cloud Function when there is a user creation or when there is a user deletion. I have to admit that here, sometimes we miss some extra events. For example, it could be interesting to have an event that is triggered when a user logs in, or when a user certifies his email or confirms his email. Events like that, for the moment, at the time of giving this talk, don't exist. We only have the possibility to trigger an event when a user is created or deleted. On cloud storage, we have different kind of events. This applies to any bucket in cloud storage. On finalize, which corresponds to the creation of a new object. So for example, when a user will upload a file from your app through, for example, taking a picture or uploading a file through an HTML page with a button, you will be able to trigger a cloud function. On delete, when an object is permanently deleted, or on archive, when you have buckets with versioning and you archive some files. And last but not least, you can also trigger an event when the metadata of an object in storage is updated. Depending on the trigger type, Cloud Function will expose the number of properties of the entity that triggered the function. Okay, for example, if it's triggered by a document, you will have the path of the document, in which collection this document is created, and so on. For authentication, you will be able to access the user details. And Cloud Function will also expose a context parameter that will provide information about the function's execution. For example, a unique ID for the execution, or what else? Parts of the path or that triggered the event, etc. Can you just confirm that you are hearing me correctly? Because since I don't...
We hear you, Renaud.
Okay,
Yeah,
perfect.
no
Then I know I'm not talking. All right. So these are examples of background triggers. But what and when can we do these triggers? For what do we usually use Cloud Function? So the possibilities are somehow endless. I will here list some of them and enter into detail. And later on, we will see during the how and how not, we will see some real examples with code. But you can do a lot of things with Cloud Functions. One very classical one, common one, is to synchronize database nodes or documents. As you may know, in the NoSQL world, it is very common to denormalize your data. Okay, when you work out the data model of a file store database, you will work out this model, you will architect your model based on the types of query you want to execute. So compared to the SQL world where you will join two tables in order to get data from two different tables, in the NoSQL world, you will duplicate data in such a way that your queries are as fast as possible. And that, for example, you only have to query one collection to get all the needed information. So in order to do this denormalization, and in particular, also to synchronize the different documents after creation, it is very typical to use Cloud Function. So as soon as the document is updated, for example, we can update all the other documents that are related to this document, kind of mimicking SQL primary key, foreign key relationship. Cloud Function is also very interesting as the glue between several Firebase services. Another classical use case is when you create a user, you usually want to create a profile, a user profile with some extra information, address, URL of a picture, company, etc. This cannot be stored in the authentication service, so you will store it into the into Cloud Firestore, for example. And you may also want to store a picture of the new user. and you will store this picture in cloud storage. So here, the cloud function will detect the user creation. You will trigger user creation, and the cloud function will create the user, will add to file store a document corresponding to the user profile, and will add to cloud storage the picture of the user. Okay, so it will be the glue between the different services. Another example is when you upload an image, you may generate a signed URL that you will store in a file store document for the user to be able to read it and use it later on. Another case where we use cloud function, it's when we have very complex business logic that can only be implemented in a backend, okay, and not on clients. So it can be because it is complex, but it can be also because it must be protected. For example, if you interact with Stripe, the Stripe payments API, you can only finalize the payment from a backend. Obviously, you cannot do that from a front end because the possibility of hacking are too high. So the Stripe API needs to receive the last confirmation from a backend infrastructure. Here, Cloud Function plays this role. Another common use case is when you don't want to expose in your app your proprietary business logic. Okay, it's called the secret sauce in the developer world. Okay, so you don't want to expose because everything that is in an app, whether it is a web app or a mobile app, can be easily reverse engineered. Okay, so you may have some specific business logic that you don't want to expose to users, and you don't want to take the risk someone reverse engineers it. So you can use cloud functions to implement this business logic. Another interesting use, still with business logic, is to implement only once this business logic instead of implementing it, for each client platform. Okay, so you write only once, and you avoid writing in different languages for Android on one side, iOS and or web on the other side. Another use case is to execute intensive tasks, because there is much more power in the cloud functions infrastructure hosted by Google than in most of the smartphones. And also it will probably be faster to do that in the backend than in the front end if it's an intensive set of tasks. Another interesting use case is also to generate dynamic content for Firebase hosting with cloud functions. So it's a bit like 20 years ago when we were using GSP servlets or Microsoft ASPs, where we were generating HTML page on demand to be sent to the browser. So here, this is something which is possible. So you can connect Firebase hosting to cloud functions, and when you will call specific pages hosted in Firebase config or specific URLs hosted in Firebase config, it will actually redirect the request to cloud function, which will generate the content and sends it back to the user's browser. But the list continues. A very interesting possibility with cloud function is to integrate with third-party microservices, or with APIs from Google Cloud, for example, or from other provider. So you can integrate like with SendGrid, which is a microservices to send email. You can integrate with Stripe. You can integrate with any APIs that expose, any service that expose some APIs on the web, okay? And like I said, you can also interact from cloud functions to all the Google Cloud APIs, like Vision API, for example. And we will have an example, a live example of how to integrate a cloud function with a Google Cloud API. Also interesting is that you can use a cloud function to be a webhook, to respond to webhooks from microservices. Okay, so in the for example, with SendGrid, where you send an email, you can ask SendGrid services to call an HTTP endpoint to send you events around an email that was sent. So SendGrid will send the email, and as soon as the user, for example, opens the email or opens an attachment in the email, SendGrid will be able to detect this event, and SendGrid will be able to call one of your Cloud Function, expose as an HTTPS endpoint, and then you will be informed within this Cloud Function of the type of event. So you will be able to update your backend and send a message to your front end. For example, you could have the list of all the emails, the marketing emails sent to a set of users, a set of targets for marketing campaign, and through Cloud Function, you will receive the events from SendGrid, and you will be able to update those file store documents representing the different email sendings. You will be able to update them with the status of each email. Okay. Also, a very interesting use of Cloud Function is to as a workaround for client SDK's limitations. You have several limitations in the client SDKs. For example, it's not possible to list all the collections of a file store database, or it's not possible to list all the sub-collections of a given file store document. This is something you can do with Cloud Function because you are using the admin SDK, and we are going later on to look at it. And the admin SDK has this capability, while the client SDKs don't have it. The same with transactions. The client SDKs, you are limited to read only unique documents, atomic documents, with Cloud Function and with the admin SDK, you are able to use queries within transactions. So this is very interesting because you can find workaround to the client SDK's limitations. Another interesting and very important use case and very important point to understand is that a Cloud Function, so you are using the admin SDK, like I have just said, you totally bypass all the security rules of all the Firebase services. So when you execute a Cloud Function, you are in full control, full access right in write, read, and so on. Okay, so it can be an advantage because, for example, let's imagine that you want to maintain a counter for the number of likes in a chat application or around specific post in a post application. You don't want the user to be able from their client to modify the counter of likes, of course. So it is something that you will do in the backend. And since you have full access to all the different file store collections and documents, you can easily update the counters through Cloud Functions. While you can, for the documents that hold the counters value, you will implement some security rules that will allow the users to read them, to read those counters, but will not allow them to modify those counters. So the security rules will be like write false, no right to write, but since you are updating it through a Cloud Function, you will totally bypass the security rule. Sometimes we have the other case where security rules, the security rule language is not complex enough to be able to cope with your specific requirements. So you might, instead of writing directly to Firestore, you might go through a Cloud Function to be able to implement specific, really specific security rules. Last but not least, a very important one as well is the possibility with Cloud Functions to implement, to assign, custom claims to specific users, a specific user. And custom claims are the way to implement role-based access rights within Firebase. And you cannot, obviously, you cannot assign a custom claim, so assign a specific role to a user from a front end, from a client SDK. It can only be done in what Firebase called the privileged environment. So it's either a cloud function or a server that you totally control, and in which you will also use an admin SDK in Node.js or Java or C++, etc. Okay. So that was a long list, and you see there are still some. I mean, like I said, the list is endless. So now let's look at how we are how do we implement cloud functions. First of all, the development environment. So you need a Node.js version 10 environment to write cloud functions. You can still use today a Node 8 version, but you have to know that it has been deprecated. And on March 15 of next year, there will be no more the version 8 executions. So it is highly advised to now only use Node.js version 10. So you need to install Node.js on your development environment, on your machine. Please go to the documentation where it is very well explained. In the Get Started section of the organization, it is explained into detail. Then you need to install the Firebase command line interface, CLI, sorry, which will allow you to deploy your functions to the cloud functions runtime, which is in the cloud. You will obviously need a Firebase project where you will, in which you will develop your functions. And then you will have to, in this project, you will have to initialize the Firebase SDK for cloud functions. So it will create an empty project containing dependencies and a really minimal sample code. And you will be able to choose either to use TypeScript or JavaScript for writing your functions. And last but not least, you obviously need an IDE for JavaScript or TypeScript. Okay. Again, I'm not going to enter into detail. It will take too long, and everything is fantastically explained in the Firebase documentation, which is very good. So I really encourage you to go through the Firebase documentation. I also encourage you to look at all the videos in the Firebase YouTube channel. They are really worth watching them because they give you a lot of information. And I mean, I would say it's a must, in particular for cloud functions, it's a must to look at the different videos. And I will, later on, I will show you where in the documentation. So when you have set up your development environment, you will open your cloud function file. By default, it's index.js file that is created by when you set up when you install the cloud function SDK, but you can very well change the name of this file. And you will first use Node.js require statements to first import the cloud function for Firebase SDK. Okay, you need this one to create cloud functions. And you will probably, if you want to interact with Firebase services within your cloud functions, you will have to install the Firebase admin SDK. And after you have installed it with require, I mean, imported it with require, you have to initialize an admin app instance. And then from this admin app instance, you are able to define the different services. For example, file store database, cloud storage, the authentication service, and so on. Okay. So when you have done that, you can write a cloud function and you can deploy it. So let's write a very simple cloud function. It's an HTTP endpoint, and any request to this endpoint will result in a Node.js Express style request and response object. So a request and response object from Express will be passed to the onRequest callback. So what do we have? We have here the name of our cloud function. Do you see my mouse? Can you please confirm?
Yeah, we do, yes.
Okay, excellent. So here we are going to export a function called hello Harus, which is an HTTPS function, and we have a on request callback, and we pass to this callback a request and a response object. So here we will simply look at the query string of the URL calling this HTTP endpoint. If there is a name value in the URL, we will use this name value. If there isn't, we will, by default, assign to the name variable arus. And then we will send back, so we'll use the response object, and we will call status and send, and we'll send back just hello, hello name. Okay, so when you have written this function, you can deploy it via the CLI just by doing Firebase deploy. And you can, if you only do Firebase deploy, it will deploy all the services declared in your Firebase project. But if you just want to deploy functions, you will do -- only functions. And you could even put a colon here and the name of the function. So again, all the detail to be found in the documentation. So let's give a try to this one. Do you see my screen here? Now you see Google. So you see here. Okay, perfect. So here we see the URL of this hello Harus cloud function. It is hosted in the US Central 1 location from Google, okay? And the name of my project, my Firebase project, is Cloud Function Talk -E5C62, okay? So the URL of an HTTPS Cloud Function is made of the location, your project name, .cloudfunction.net, and then you have your Cloud Function name. And here you see I have added a query string. So if I enter it, the Cloud Function will have to start. So we'll later on speak about call start. You see here, I see the result of the Cloud Function where I sent back a JSON with a hello liter. If I remove the query string parameter, then I get the hello Harus default sentence. Okay, you see after the first call, the Cloud Function, I can go and ask the robot to say hello to Casper. Okay, so it's really rapid, really fast. Let's go back to the slide. Present. Yep. Good. So we have just deployed and triggered our first Cloud Function. So now it is maybe the most important part of the presentation. It's about the Cloud Function, about the lifecycle management of your Cloud Function. Okay, managing the lifecycle of your Cloud Function, and in particular terminating them correctly, is absolutely key. Okay, it's really, really important. Why? To make sure that the Cloud Functions instance running your function does not shut down before your Cloud Function successfully reaches its terminating condition or state. As a matter of fact, most of the Firebase operations are asynchronous. For example, when you write to the database, or you read from the database, or you write to cloud storage, or you create a user, all those methods from the Firebase services are asynchronous. And it's only when all of the asynchronous work of your Cloud Function is completed that it is safe to terminate it. And you should not let your Cloud Function terminate the Cloud Function platform, terminate your Cloud Function while some work is still going on. And what happens, and you can find a lot of questions on Stack Overflow about that, is that you have the feeling that your code failed mysteriously, because what may happen if you don't correctly manage the lifecycle, it may happen that sometimes the Cloud Function platform stops or terminates your Cloud Function immediately, but it may also happen that the instance is still running. So even if you haven't managed it correctly, and I will show you later on how to do that, the Cloud Function instance is still running, so your Cloud Function has the possibility to reach its terminating condition. So you are seeing in your log, in your testing, you are seeing sometimes it works correctly and sometimes it's not working correctly. And you are puzzled and you don't understand why. Most of the time it's because the lifecycle management and the termination of the cloud function is not done correctly. Another reason why to do that, which is in my opinion less important, it's to avoid excessive charges, okay? Because functions, if you don't terminate them, they may run for too long, you know, and before the platform kills them. I will rapidly look at the time. It's quite late, and I still have a lot, so I will try to accelerate. So how to terminate a cloud function? There are two cases. For HTTP triggered ones, so the example we just had with hello Harris is an HTTP one. You will have to send back a response, okay, with a send, redirect, or end. For background triggered one, so remember the one triggered by a new document in FileStore, by a file that is deleted in cloud storage, you have to return a promise, or to return null, or to return an object. So what is a promise? In JavaScript, a promise represents the eventual completion, so the completion in the future, or the failure of an asynchronous operation. And it also represents its resulting value. And we have three possible states for a promise. Pending, so it means nothing has happened so far. Fulfilled, it means it has reached the asynchronous execution has reached an end successfully. And rejected, there was an error. And when you work with background triggered cloud function, returning a promise will tell to the cloud function platform to wait until the promise is fulfilled or rejected before cleaning up the function. So it's a way you will avoid the platform to possibly kill your cloud function in the middle of the execution. It's by returning in your code, returning a promise. And then the platform will see, oh, here, something is happening. I cannot I cannot kill this cloud function. I will wait to receive the result of the promise, okay? If you don't return a promise, if you return anything else, the cloud function platform may terminate your function immediately. So let's try to add a call to an asynchronous FileStore method, okay? We have our hello Arus cloud function. In addition to sending a hello message, what we are going to do here, we are going to create a FileStore document where we will add the name that was called through the HTTP endpoint, okay? So we still have on request cloud function, we still calculate our name, and here DB is actually admin FileStore, like I shown in one of the previous slides. I call the collection hello Arus log, and to this collection I add a document, okay? And when I have finished, so the add method returns a promise, okay? And then I will use the then method to materialize, I mean, to treat the result of this asynchronous call to this method, okay? And in case there is an error when executing the method, we can catch an error, and then we are in the case where the promise is rejected, while the then will be triggered when the promise is fulfilled. The catch will be triggered when the promise is rejected, okay? So the admin SDK returns a promise when you call an asynchronous method, okay? So all the asynchronous method of the admin SDK that you use within Cloud Functions return some promises. So you have to use those promises correctly. So let's, hopla. Do you see my screen?
We do, yes.
Okay, sorry, I had a bit of problems. So here, I'm going to call this second cloud function, which is called hello Arus log with the name of Casper. So I click on it. I enter, and I have a problem. That's new. Oh, that's the demo effect. Why it's not working? That's strange. This one is working. Yeah. So this one should work also. No. So here I'm switching to the Firebase console, where I'm going to look at the log. So I'm in the Firebase console. I click on the functions vertical menu item, and here I have some tabs, and I will head to the logs tab, and I will try to understand why I have a problem with this function. If it doesn't work, we will continue. So we have some problem. Add post. I have here. I have a normally everything should be okay. Okay, sorry for that. I will just continue. So here the goal of this cloud function, as you have understood, is to in addition to sending back a result to the caller, it will before sending back the result, it will create a new document in a specific collection. Very important. Most of the time in your cloud function, or at least many times, you will have to manage several asynchronous calls. For example, you read from one document, and based on the value of some fields of this document, you will write other documents into FileStore. Okay, so we have two cases. Either we have some sequential calls. So we call we execute a first asynchronous call, and based on the result, we execute a second one, and based on the second one, we execute a third one. And for that, we have to chain the different promises with Zen. Another case is when we want to execute several calls in parallel. And to do that, we will use promise all. Let's try to see that in real time. I hope it will work. So to manage several asynchronous calls in sequence, like I said, we have to chain with the Zen method. We have to chain the promise. So here we have an example where we are. So it's a background triggered cloud function, which is called create FileStore doc. Okay, and it is triggered when a document is created under the collection named collection. Okay, so we have the document path, and we have the onCreate callback. So each time a document with a specific ID is created under the collection named collection, this cloud function will do something. And based on this, the result of the do something asynchronous call will do something else with the result. And based on the result of this second call, there will be a third call to an asynchronous method. Okay, and here what's important is the return and the then. So we return the entire chain of promises, and which within each then we return the promise returned by the asynchronous call. Okay, and since then and catch return promises, we can change them. So it's really important. Here we are in a background triggered cloud function to return the entire chain, meaning that you should not forget the return here, and you should not forget the return in the different Zen. Okay. So I have an example here. I hope it will work. It's when I create a document within this specific collection. Okay, what we are going to see. We are going to fetch, to query a specific collection named country, which contain different documents identified by the country code. And we are going, based on this call, so we will fetch one specific document with a specific country code, and we will get a document snapshot in the then callback. And this document snapshot contains the data of the document we have just fetched. And we will, based on this data, we will update the document that was written initially in the post from app collection. And we'll update this document with the data we got from the country document, the country name and the capital city. So let's give a try. It's not that. So here, I'm now in the Firebase console in the database section, and I see in countries that I have different countries, okay? And in each of these documents, I have a capital city and I have the name of the country. So in post from app, I have already a document. What I'm going to do is to create a document with only country code. So I will add a document. I will use the auto ID mechanism, and I will here enter the country code of Denmark. And you see, it is created, and right after some couple of seconds after the document was created, the cloud function was executed, and it looked into the country's collection. It looked for the DK document, and it took the data from the DK document, and it updated the newly created document. Okay, this one worked. Let's continue. Like I said, when you want to manage several asynchronous calls in parallel, you have to use promise all. So let's dive into a bit more complex example. It's a HTTP on request one. I hope it will work, but the idea is to copy all the countries. So we will first, to work with promise all, we have to pass to promise all, we have to pass an array of iterables containing we have to pass an array of promises. So in other words, an iterable containing promises. So we build, we declare an empty array here, and then we fetch the entire collection of countries. We get a query snapshot, and we are going to loop on this query snapshot to get each country, and we will declare two variables, capital city and country, and we will push to the array of promises. We will push a call to the set method, which returns a promise. And what is this set method going to do? It will update, it will create new document in the cities collection with an ID corresponding to the capital city name, and it will set the country, and it will set a Boolean capital city equal true. So when we have this array of promises, we call return promise all, which returns a promise, and then we are able to, we get an array corresponding and with the same size of the array of promises, and in the same order than the array of promises. Here in our case, it is an array which contains non-null promises with void, because actually the set method doesn't, returns a promise containing void. But we can use this array to calculate the number of cities documents that were created. So let's cross our fingers and to see if this works. Yeah, it works. So we have 5 city documents that were created. So now if we go back to our console and to our database console, I have to refresh the console. And from the country, I see now a new collection, which is called city. And you see, from the countries document, we have gone through the collection. And for each document, we have taken the capital city name, and we have created a new document in the cities collection. And we have, to each document, we have assigned two fields, the name of the country of the city corresponding to the city, and also the fact that each of those cities are capital cities. Okay. So that was an example of how to deal with parallel calls. So this part was really, really important. Okay, you really have to correctly deal with the different asynchronous methods and to deal with the promise they return. So you saw this code maybe looks a bit can look a little bit complex with a different call to then and to catch and so on. Since with ECMAScript 2017, this is a JavaScript edition, introduced the possibility to use async await instead of then. And that's quite interesting because all your promise-based code can be now written in a much more cleaner style, okay, more like synchronous code. So rapidly here, you have one of the cloud function we looked at written with then, and here you have it written with async. So first of all, you have to see that we declare the this inner function here, this anonymous function, we declare it async, okay, while here it is not the case. And while here we return the entire chain of promises, here we first we use await keyword with our call to the get asynchronous functions. So we get directly, we can directly declare the document snapshot this way. So document snapshot equal await the result of the gate, while here we had to use the then in order to get the document snapshot. And then here we can directly call await snap.ref.update. And when this is done, when this asynchronous execution is done, we return null. Okay, while here, this is more or less corresponding to the first return here, which aim is to return the entire promise chain. So the code is much more readable, easier to understand, and while it is still asynchronous, it is written like if it was synchronous. Okay, so I encourage you to use this this syntax. It may be a bit complex at the beginning, the first time, but very rapidly you will become used to it, and it will really ease your life and make your code much more cleaner. Let me drink a little bit of water. Is it okay if we go a bit later than planned? I'm sorry for that.
Sure, go ahead. If people wanna, if they have some other things to do, they can catch up with the video tomorrow. Okay. But I think it would be nice to hear what you have to say.
Yeah, sorry for that. The first time I do this presentation, so it was difficult for me to assess the duration. And if some of you have to leave, do not hesitate to send me emails or to connect with me on Twitter, and I will be happy to answer any question. Okay, so this one I will pass it really fast. So we've seen some examples where in a cloud function we interact with Cloud File Store, but like I said, in addition to interacting with Firebase services, cloud functions can interact with any API exposed on the web. So here we have two examples. On the left side, we have an example with Stripe. You see where we call the payment instance.create method, and here we use the async await mode. Okay, and so we call exactly the same we did with the FileStore method. We are calling the Stripe asynchronous method in our cloud function. Okay, the same with Mailgun, which is a service which allows you to send email. So we will create an SMTP transport object, some a set of options, and we will await SMTP.sendMail. And when this is this asynchronous call is completed, we return null here and here the same way. Okay. One thing to note is that if you want to call APIs that are not hosted by Google, you need to be on the Blaze plan, pricing plan. So you need to activate the pricing, the Blaze plan, which so you need to have a credit card and you need to activate this plan. Before you have to pay, you will need to do a lot of cloud function execution. The cloud function pricing is very, very generous. There is a free tier, and which is generous, and after that, let's look at it. It will be better, and I'm sure I will not say some errors. Where it is? It's here. Pricing. So cloud functions. You see, you have so this is a free tier, and this is a Blaze plan pay as you go. So you have a free 125,000 invocation per month. Okay, plus you have some. Indeed, you have to pay for the volume inbound and outbound. And with the paid Blaze plan, it's $0.4 per million invocation. So before you start to pay, I mean, you have to really call a lot of cloud functions. So it's not because you have to switch to the Blaze plan that your credit card will be consumed, that you will have to pay. Okay. I had the demo web app. I think I will do it at the end for the ones that want to stay, because it's quite interesting in terms of architecture. But I will pass it for the demo, for the presentation, and we will look at it at the end of the presentation. So you had some example of code. And I really emphasize the importance of correctly managing the lifecycle of your cloud function. Now, let's look at other aspects. First, environment variables. So you can store and retrieve environment variables for your project through the built-in environment configuration system. So it's quite interesting for having your code more portable and in particular for switching between different environments. Okay, so the advice from Firebase about having different environments for development, testing, production is to have different projects. So you can very well use the same code base and you deploy it to your different projects. And you rely on environment variables to inject parts of your code that is depending on the environment. It's also interesting for storing node modules configuration, for example, APIs key. Okay, so it's quite easy to set and retrieve environment configuration through the CLI. You call this command functions config set, and then you can add a different variable name and with their values. What's very important is that you should not have any space between and before and after the equal sign. Okay, and to get it, to retrieve it, you call Firebase function config get in your console, and you will get a JSON representing all your environment variables. You can also do that through the Google Cloud Platform console. And in your cloud function, you access the environment variables like that. So you declare a console variable, functions.config, and the ID of the environment variable. Very easy. Configuration and runtime options. So there are several possibilities. The most important ones or the most interesting ones. It's first to be able to choose the Google Cloud region where your cloud function is going to be executed. So you do that by adding to the cloud function declaration. You add a call to the region method, and you pass the name of your of the desired region. Okay. By default, your cloud functions are running in the US Central 1 region, but you can choose another region if you want, one or more other regions, because you have the possibility to have the same cloud function but deployed in multiple regions. So in your index.js file, you may have the same function but with a different value here in a region. In terms of runtime option, you can adapt the timeout duration. The maximum value is 9 minutes, and you can also adapt the memory of your cloud function. So you can do that either through your code, but you can also do it through the Google Cloud Platform console. And let's have a look at that, because it's interesting to rapidly show you how to. Yeah. So here I'm in the Firebase console. Okay, I have the list of the functions that are deployed in my project. Okay, I can see the log, I can see the usage, and so on. But Cloud Functions is not a product that is limited to Firebase. It's a Google Cloud Platform product, and you can navigate into your Firebase Cloud Function through the Google Cloud Platform console. Okay, so you go in the console menu here in Compute Cloud Functions, and you see the exact same list of function. And it's here that you can so here you see why there was an error before. It's because it was requested for authentication. I don't know why, but so this is why we got this error at the beginning of the demo. Later on, we can have a look at it. But let's rapidly look where you can configure the different configuration option. I will edit here the cloud function, and at the bottom, at the bottom here, I have a section that I can expand, and here I can set up the timeout, the region. I don't think I can set up through this page, but here I can set up the timeout and the memory. So the timeout is here, so I can go up to 9 minutes, and the memory allocated is to be selected here. Okay. So two ways. I switch back to the presentation. Two ways to set up these runtime options through your code or directly through the GCP console. You cannot do that through the Firebase console. You have to do it through the GCP console. Monitoring and testing, I will go rapidly on this slide because the time is running. Of course, you have world-class possibilities and world-class tools to monitor and test your cloud functions. You can write to logs, either through a simple JavaScript console log or console error and so on, but you can also use the Stackdriver logging library for Node.js, and then you can look at your logs through the Firebase console, through the Firebase CLI, so you can get in your IDE or in your terminal, you can get the logs. You can use the Stackdriver UI, and you can also use the GCP console. You can also emit some errors to Stackdriver error reporting, and you are able to view those errors through the GCP console. In terms of testing, the Firebase CLI includes a Cloud Function Emulator, which can emulate 3 types of functions: the HTTPS functions, the callable ones. We can later on discuss about the difference between the two, and the Cloud File Store functions. So within the emulator suite, you have multiple emulators which enable you to test cross-product interactions, for example, Firestore. So you don't have to deploy and to use the Firebase, the online Firebase console to test, for example, a cloud function which interacts with Firestore. Okay, you can do all of that within the emulator. And also, if I would have more time, I will speak about the possibility to retry automatically asynchronous functions if you get an error. Here, what's important is to write independent, sorry, it's difficult for me to say it, cloud function. So meaning that actually Firebase guarantee the fact that the cloud function will execute at least once. So it may happen in some rare cases that your cloud function is executed several times. So you need to write it in such a way that it will always generate the same result. Also an important point, and there is a lot of blog articles and videos in the Firebase documentation. It's about the call start. So Cloud Function is a serverless platform, and you have somehow to pay for all the advantages of the serverless model. Okay, and in particular, there is a call start. If a Cloud Function is not used, the Cloud Function platform will clean it, will decommission it, will stop it, and when there will be a call to your Cloud Function, depending on the different libraries to be loaded, there might be a small delay before the Cloud Function can execute, because the platform will have to load and initiate all the different libraries. Difference between HTTPS and callable Cloud Functions. Callable Cloud Functions are, I will just switch to the documentation, it will be maybe easier. Callable Cloud Functions are similar to HTTP Cloud Function, but they are it's not that, this one. They are really dedicated to be called from your application. Okay, so the big advantage is that when you use a callable Cloud Function, it will automatically include in the request the Firebase authentication and FCM tokens. So it means that you will be able to automatically identify the user that is calling the Cloud Function. Okay, and so it will automatically deserialize the request body and validate all the auth token. So you don't have to do all this work yourself. You can directly get those objects, those elements into your Cloud Function. While in the pure HTTP one, it's much more complex. Okay. So that was the how section. Let's now rapidly look at how not. Something that I see quite often on Stack Overflow, it's when a developer wants to call an HTTP Cloud Function and returns before work completion. So let's have a look at this code here. So the Cloud Function is triggered, and then the developer immediately sends a response to kind of acknowledge that the heavy work has been started. And then after this line, the developer starts to do some asynchronous heavy work, and waits for the result. The problem here, if you remember what we said at the beginning, is that as soon as this line is executed, a signal is sent to the Cloud Function platform to say, okay, you can kill this Cloud Function because I've sent back a response. So in most of the cases, especially if it's heavy or long execution, it will be stopped in the middle of the execution. So what to do in this case? You have to use a pub/sub Cloud Function. So you declare the pub/sub service, the pub/sub library, sorry, and then you will publish a message to the pub/sub infrastructure. So for example, here we have a pub/sub topic that was declared, which is called heavy work, okay? And we have a payload that we will send together with this message to pub/sub, and it's a file name of a big image, for example, that we want to process. We want to have a specific process by the Cloud Function to take this image and to do something with this image. And we want to send back the response to the user before this entire process is done. So what we do, we publish a pub/sub message to this specific topic. And then this will delegate the execution to another Cloud Function. So now, after all this line, and when this asynchronous call, you see the await keyword, when this asynchronous call is completed, now it is safe to send back the result to our client, to our caller, okay? And if you need to acknowledge the user when the work is completed, there are other ways. You can send a notification, you can send an email, or a nice way is to write to a 5-star document that you watch from your app with a listener, okay? I can show an example with the demo I'm going to do at the end of the presentation. Another very common error is to forget to change and return promises. You know, I said that managing the lifecycle of your Cloud Function is really key. It happens many times that you have code that doesn't correctly return the chain of promises. Here, for example, we miss here a return. So we return correctly here within the then callback, but we don't return the chain. Here, on the other hand, we return the chain, but we don't return the result. We don't return the promise returned by the update Cloud Function. So it's really easy to forget or to manage that in an incorrect way. And again, it is really key. Another common error is to create an infinite loop. For example, I mean, you have to be careful to avoid any situation in which the result of your Cloud Function actually re-triggers again the function. Let's have a look at this example. So this is a 5-star Cloud Function, which is triggered when we update the document. And what do? We take through context params.userid. So we assign to this variable the value of the ID of the document. So here we are in a collection called users, and we trigger this Cloud Function when one existing user document is changed, okay? So we get the user ID, and what do we do here? We write again to the same document through admin 5-star collection users, the same document, and we update it with a new status. But what's going to happen is that since we are modifying the same document, this Cloud Function will enter into an infinite loop. It will run again and again and again. So how to handle that? You have to work with the two different objects that are present in the change object. We have change.before and change.after, which represent the value, the set of fields of the document before the execution and after the execution. And here we have to test if there is a difference between the value of status. And only when the value of status before and after the execution is different, then we can update the status, okay? If it's the same, then we don't do anything, we just return null, which means that the platform can stop the Cloud Function and clean it up. So if by mistake you do this error, which is quite common, especially at the beginning, how can you stop the execution? There is only one possibility, is to delete the Cloud Function in your code and redeploy it. I don't know any other ways, but maybe there are. But this one I know it does work. And also, you should not use callbacks instead of promises. Okay, there are some libraries that you want to use to I don't know, to generate a PDF, to read a CSV file, etc., etc. And you find a library, a Node.js library that seems to fit your need, and but then you realize that it doesn't return promises. And then that's a problem, because like we have seen, you need to work with promises within Cloud Function. So one solution is to promisify the callback by wrapping it in a new promise. You will find a lot of literature on the web on how to do that. Another common mistake is so as you probably know, with the Firebase databases, so Firestore or the real-time databases, you have the possibility to set up listener from your client, and the listener will listen, will watch a specific collection or specific document or a specific real-time database node, and watch if there are some changes. So this is very interesting in terms of user interface reactivity, but in a Cloud Function, it's not really what you want. What you want is to read a specific document or a specific database node once and only once. So you should not use listeners, but you should only read once. Also, since we have a timeout of 9 minutes, we should not execute very long operation. If you have very long operation, you should choose a different platform, Compute Engine or any other ones. Another important point is to clean after your operation, in particular with cloud storage. If you, for example, you create temporary files, you need to delete them. And another common mistake I see quite a lot on Stack Overflow is to use promise-all within a for each loop. Again, I encourage you to make a search on Google, promise-all and for each, and you will see that they don't go very well together. So the solution is to again create an array of promises, populate this array within your for each, and sorry, I realized that I was not clear for this last point. So the problem here is to not use the await keyword in a for each loop. Sorry, I was not clear. So if within a for each loop you use the await keyword, you will have problems. So if you, like I said, if you look on Google, await for each, you will rapidly find some details. And the solution is to use promise-all. So instead of using await within the for each, you should, like we have seen before, you should create an array of promises, populate it within the for each, and after the loop, call promise-all with this array. And I think we have reached the end of the presentation. So I would like to thank you. We can open the floor for Q&A. We can have a small demo if you want. Just tell me, it's up to you.
Renaud?
Yes.
I think there might be a few people that have to leave, so maybe we can do a couple of few quick questions.
Yes, no problem. It's why I asked you what you prefer. So yeah, let's go for questions.
We'll just we'll do them reverse. So Brian had a question. If you could tell us a bit about scheduled Cloud Functions, how that relates.
So I will, you know what, I will heavily use the documentation. So scheduled Cloud Functions are done through, like I said, through a mix of Cloud PubSub topic and the uses of Cloud Google Cloud Scheduler. So okay, so it's very easy. You declare your function as function pub/sub scheduled, and here you define the frequency of the execution. Okay, so here you can use some natural language like that, or you can use some more I don't know how to say that, more standard cron job definition. Okay, what's important to note here is that exactly like with the background cloud function, you have to return the promised chain. Okay, apart that, there is nothing more to say. It can go up to the minute, so you can trigger a function every minute. Typically, it's something I do, for example, with email confirmation. You know, you remember I told you that we kind of lack some triggers in the authentication verified his email, you know. And I'm currently developing an application for a client where the admin wants to receive an email each time a user has verified his email. So since we don't have any trigger here, we run a scheduled function every 2 minutes, which check if there was some change to some of the users. That's it. I cannot say much more. You can do exactly the same thing than in other functions. So you can interact with Firebase services. You can call an external service, etc.
That makes sense. And is it like in terms of cold starts? We never really covered the. So I guess I can ask a question here as well. But how accurate is the scheduled function? And also maybe you can say a bit about what is the best like practice for if you can't live with the cold starts? Like, are there any patterns that you can?
Yeah, there are some patterns. Let's see if I have. So here in tips and tricks, you have. So I do recommend. You remember I said you should look at the videos. Let's just make a parenthesis. I do recommend you look at all those videos from Doug Stevenson. They are really a must. Okay. Start by the first one and watch all of them. Okay, so in terms of where it is it here? I mean so this video will give you all the details, but in a nutshell, cold start is directly dependent on the number of modules you load when you start the cloud function. Okay, so if you need a library to create a PDF, if you need the library to interact with the Vision API from Google Cloud, it will take time to load the library before the function executes. So the main way to deal with the cold start is to only load the correct libraries only when you really need them. So as you have maybe understood, in a one index.js file, you can have several cloud functions, and it may happen that some of them actually don't need a specific library. So there is a specific way to only load this library within your cloud function. I don't know if I'm clear, but it's difficult to explain in 2 or 3 seconds, but I really encourage you to look at this specific video, and also to do a Google search on that, because there are also some extra material in the Google documentation, Google Cloud Function documentation. Okay, but mainly the idea is to declare and to load the library within the Cloud Function itself.
So that makes. But the thing is, of course, you may have a heavy duty function with a lot of imports that you want to kind of keep alive. I think in the past people were doing
the keep alive. For me, it's a myth. You know, it's not. I mean, there are people that use a scheduler to call a cloud function every minute.
Yeah, exactly.
Yeah. Okay. It may work, but it may not work as well. Like I said, if I mean, unless you call a cloud function that runs for 9 minutes, then you call it every 2 minutes, you may cover a continuous continuous period, But if it's just a small cloud function and you call it every 5 minutes, hoping that the platform will stay alive, it may happen, but it may happen that it's not the case. So I don't think there is any magic recipe magic trick here. Okay. Again, if you cannot optimize it with the method I've just pointed out, at one moment you may have to consider another approach. It's a bit the price to pay for the serverless mode and also the price you pay for this serverless service, which can be very, very low in many cases. If you need another approach, and then you have to change to choose another model.
Right. Then we have a question about best practice when multiple developers need to work on the same Firebase project. Could be running in a single project for each developer, or running the local emulator suite, or something completely else. I'm not sure I understand, but I think you can. What's the?
It's difficult. I don't have a fantastic answer for that, I will say. Working with the emulator is nice, but it's only covering the testing, So yeah, you can work on your personal basis. So if you use a common repository, you get the code, you modify it, you test it in your emulator, so you are in local. But so for testing, yeah, it's possible. But the problem will come when you want to deploy. So you have to configure your CI CD correctly in such a way that your cloud function is deployed when it has to be deployed, and the deployment is triggered by the correct developer. So you can develop locally, you can test locally, but at one moment you will have to take care of managing who is pushing the code to the backend.
Okay. And I think we can. Oh, there is a question here. Recently, I've seen we can use Java for cloud functions. I'm new to Node and need to work with Java. Is there a trade-off, assuming in performance or cost, when working on Java?
I cannot answer on the performance and cost, but what I can say is that Java is an option for cloud functions that are developed through the Google Cloud Console. It's not an option for a cloud function for Firebase. Cloud function for Firebase, it's only Node.js. But you can very well write a cloud function, a standard Google Cloud Platform cloud function, which will be triggered, for example, by one of your Firestore trigger. Okay, but then you will have to use the standard GCP way, and you will not use the Firebase CLI. You will not use the Firebase console, etc. So yes, it's possible, and it's not only with Java, but it's also with Go, with Python, etc. But then you are working in the framework of Google Cloud Platform and not in the framework of Firebase.
And of course, you're not allowed to tell, but could you imagine there would be any moves from Google to move that into Firebase cloud functions as well? Could be other, like Kotlin or?
I don't know. I have no. They rarely communicate plans. They don't communicate dates of delivery of new features. So I've never heard about any plans with that so far. So yeah.
All right. I think we might have, there were some questions earlier and there was a bit of chatter in or a bit of writing in the chat. So maybe some of them were answered. But if you still have questions, please write them in the chat. And then we will go to the demo now. And then we will take the last questions after that. And then if you have to go, you can just, I guess, say bye in the chat. And thanks for joining. And we will enjoy your company a bit more and see an awesome demo.
Thanks for joining. For the ones that leave now, thanks a lot, and sorry for being too long. And do not hesitate. At the end of the presentation that you will receive tomorrow, I have put some links to connect together. So do not hesitate to connect with me, and I'll be happy to interact with you.
And we will send the slides through the Meetup API and stuff, and then everybody can contact you directly.
Okay, so the demo, it's an app that is called Travel Translator. So it's through this URL. So please write it down because I will or enter it into your smartphone browser, and because I will switch to a Medium article which explains and present it. So the idea is to you take a picture of a text, and then it will be automatically analyzed through OCR, optical character recognition, and it will be translated. And then you will receive the translation of the image. This is what I have called it Travel Translator, because it can be very handy to translate a restaurant menu or a sign or a museum brochure, whatever. So I will let this slide again during a couple of seconds, or during 30 seconds, and then I will switch to the Medium article to explain how it is done.
And if you can remember that, then it's travel-translator-app.web.
Yeah.
Might be more.
Yeah, that's true. Yeah, you're right. So this is the Medium article that was published on the Firebase developer publication, and actually it shows how you can create such an application in 25 lines of code. Okay, so the Travel Translator app works as follow. So the first screen you see, you have a button which allows you to take a picture. So it's a web app, huh? So you click on the button, it opens the camera of your mobile phone. You can click on the camera button. Depending on the smartphone, it may be different, but you have to take a picture and confirm that you want to use this picture. So as we see here, okay, I click on camera. Sorry. Hello. So the picture is uploaded to cloud storage. Then a cloud function is triggered. I will explain that into detail later on. As soon as the file is uploaded to cloud storage, there is a cloud function that is triggered that will trigger the OCR of the image, and then will translate the result of the OCR. Okay. Do you still hear me?
We hear you.
Yes.
Okay, thank you. So here is through a diagram the how this application works. So from your web app, first you will take a picture and you will upload this picture to cloud storage. Right after that, you will set a listener to a file store document that actually does not exist. But you have the ID of the document because it is exactly the same ID than the file name that you have uploaded to cloud storage. So this is quite interesting because it's a way to wait for the result of a cloud function work. Okay, so it's not only through HTTPS cloud functions that you can trigger them from your your application, you call an HTTPS cloud function, there is some work executed and you get back a response in your browser, but you can very well do something similar with a listener to a file store document that you update accordingly to the Cloud Function lifecycle. So we upload the file, we set a listener to a document that is going to exist, okay? Then the Cloud Function is triggered. It sends the image to the Cloud Vision API and triggers the OCR of the Cloud Vision of the image. Okay, Cloud Vision API executes the optical character recognition and sends back the resulting text to the Cloud Function. And at this moment, the Cloud Function creates a new document in Cloud File Store, the document that actually the web app is watching, and which has the same ID than the cloud storage file. And as soon as the document is created into File Store, and obviously this document contains the text of the image that was generated by the Cloud Vision API, a Firebase extension, it's a new product, I mean, not really new now, but it has less than 1 year. And actually, it's a cloud function. Behind Firebase extensions, you have cloud functions. There is a specific cloud function that will use the Translate API from a Google Cloud Platform to translate the text into one or more different languages. And as soon as the Firebase extension has executed the translation, the Cloud File Store document is updated, and at this moment, the trigger is triggered. The watcher is triggered, and the translated text is shown in the application. So I don't know if you were able to test the application. There is a cold start at the beginning, but after several times it should be quite. I mean, it should be like 5 to 10 seconds. If you don't say anything, I make the assumption that it works. Okay, so let's look now at the code. So the application itself is done with Vue.js, but in the article we show the code like if it was done in a simple HTML page. Okay, the idea was not to detail the Vue.js code, but to really focus on the interesting code from a Firebase perspective. So what's happening? You upload a file. Okay, so we have a handle files function that will take the file. Okay, and first we'll create a new document reference. So it will call the doc method of the collection OCR translations. And what this doc method going to return is a reference of the new document, because we call this doc method without any parameter. So it returns a document reference, and from this document reference we can call the ID. Okay, so if you remember when we were looking here at we are in the file store database, you remember when I created a document, I could ask for an auto ID. Okay, so it does exactly that. It returns a unique ID across the file store database. Okay, so I have a unique ID, and I use this ID to generate the file name of the file that I have just taken with my camera. I've just got in my mobile phone with my camera, and that I'm going to upload to Firebase storage. So I declare a file reference calling Firebase storage.ref, and I pass the folder and the upload file name. So here, remember, I'm in the client. I'm using the client JavaScript SDK, and with this file ref, I call the put method, which is asynchronous. And surprisingly, I'm using a then, which means that when the upload is finished, I can then declare a file store doc listener. using on the doc reference, which does not exist at this moment, I call the onSnapshot method, which will set up a listener. And then within this listener, I make a test if the document exists and if this document has a field called translated, then I just display the two properties of the translated object, which are the English translation and the original language. Okay. So if you look at Firebase extensions, just to, if I go here, extensions, like I said, Firebase extensions are kind of pre-packaged cloud functions that you can use in your project and that save you time because they are implementing some common use cases. Okay, so you can resize image and you can translate text. And what you can do with this one, you can translate to several different languages. So the application here translate everything to English, but it would have been totally possible to translate in other languages. Okay. So this is in the client. This is what we have, nothing more. So around 10 lines, not more. Okay. Now in the cloud function, what do we have? Again, it's very, very short. So we have a cloud function which is called OCR image, which is triggered when an object in the storage service is created. So it's the onFinalize trigger, if you remember. And what do we do? So we get the path and the content type. We extract from the file name, we extract the file store document ID, this famous document that we are watching in the application and which does not exist at the moment. And what we do, let me remember. Yeah, if it's not an image, we just create an error and we return null. Okay, but if it's an image, we declare a new vision client image annotator, and we call the text detection method on this client, on this vision client, and we get the results. And one property of the result object is text annotation, and then within text annotation, we have a description sub-element, and we have a local sub-element. And with the input and the original language, we update the file store document. Okay, we update it with the input, with the original language, and with the file path. Why is that? Because we will later on, at the end, we will delete the file that was uploaded based on the value of file path within the file store document. We could have done that in the same cloud function, because here we don't need anymore the file because we have already OCR it. We could have deleted here, but in order to save some time, we do that later on. There is this cloud function here, which is triggered as soon as this file store document is created. Okay, you will find all the explanation in the article on why and how this is done. And then the rest of the work is done by the Firebase extension, which was configured in such a way that here that we translate only to English. We translate documents that are created in the OCR translations collection. The input field is input, and the resulted translation is saved to the translated field. This is why here in the listener, we look at we look at the property translated, and that's it. In 25 lines of code, we have implemented an application that just translates any picture you take with your smartphone. So what's interesting here is that we take advantage of the listening capabilities of either the client SDK. So here we are waiting with the listener. We are waiting here that this document is updated with the translation, and we also take advantage of the triggering capabilities of the cloud function in the sense that as soon as a file is on cloud storage, it is immediately sent to Cloud Vision API. As soon as Cloud Vision API gives back the result, we create a file store document. As soon as this one is created, a Firebase extension is triggered, and as soon as Firebase extension writes back the result of the translation, the listener here display in the application the result of the translation. So I think it illustrates quite well how you can mix and match the different services, and in particular how Cloud Function is the glue between all those different services. Okay, and what's interesting here, like I said, the Firebase extension, it is shown here as only one element, but actually here it is Cloud Translate API. Okay, so we are mixing Cloud Storage, File Store, Cloud Vision API, Cloud Translate API, all of that with Cloud Function in the middle. So it's in my opinion, it's a nice example of what we can do with Cloud Functions as the glue of the different services. And with that, my presentation is finished. I'm happy to answer other questions. Again, I apologize for being so long. I hope you enjoy it.
Not to worry, that was very impressive.
Absolutely enjoyed it. And I think there's still time for a few more questions in the chat and reactions. I think to me, this is also really the, like your demo really exemplifies this, how powerful it is that you can glue the core features together pretty seamless and in a very efficient way. And then in very few lines of code, you have a very powerful functionality that's scalable and available on devices through a web platform. And you know, you have all this pretty much unlimited backend. I mean, of course, your wallet determines how many times you can run it if it gets really popular. But I think it's amazing the architectures that you can create this way.
Yeah, and about the money, I used to say to my customers or that if it appears that there is a lot of calls to your cloud functions, it means that you have a lot of users, you know, and usually it means that you monetize your app, so you'll be happy to pay for Firebase or Google Cloud because it will mean that you get a lot of users. I see there is an extra question here.
We have a question here. Are there any good practices to declare functions for when the project gets big? Like
yeah. So it's a part that I could not. I wanted to cover, but I could not cover because of the time. It's how to organize your functions. So again, I will advise that you have a look at the documentation, and you can, of course, like you will do in any Node.js application, you can write cloud function in multiple files, okay, and take advantage of the export-import capabilities of Node.js, okay. So here you have in the documentation you have everything that you need to use to organize your code in a proper way, and this is also something you can use to separate the function in different areas. You know, if you want to distribute work with different developers, it's also an option to make things clean.
But of course, you can. I guess that I don't know. And this is probably covered here, but you could have one massive function that does everything in tons of asynchronous calls, or you could try and decompose into a lot of smaller functions that you would then call from your functions.
Yeah, you can very well organize with normal functions. Okay, so your cloud function can be one line that calls another standard asynchronous JavaScript or TypeScript function. Okay, so again, you are just writing a Node.js code and a JavaScript code, and you can very well call a standard function, and if this function triggers or uses some asynchronous call, but this function will probably be an async function, and you will call it with a wait. But you can really organize your code, and you can also reuse. You remember when I said that you can have the same cloud function deployed to different locations. Obviously, here within this code, you will not write several times the same code. Here, you will deploy. You will have the declaration, several declaration, one for each region you want to deploy the function. But here you will call a standard JavaScript function that will contain all the work, all the code to be executed by the function. Okay. So I mean, there is no difference than a standard JavaScript code or Node.js application. I mean, just as soon as you correctly export the cloud functions with the correct declaration and the correct callbacks, you can do whatever you want.
All right, I had a little, and this is because one thing I never use Cloud Functions for like an API. And I would imagine that if you have a lot of traffic, you might get the same requests. So is there any sort of caching options for Cloud Functions in the same way that you might put in a web server? Is that something that's built in?
Yeah, I will say yeah, but I have to admit it is not an area where I'm really specialized in. So I've rarely used this possibility that I was rapidly mentioning during the when. So here, yeah, here, okay. Generate dynamic content for Firebase hosting. Again, the documentation will help you, and I think it's in the hosting that you will here serve dynamic content. So yes, there is yeah, this video is also very good. There is a certain level of caching, okay, but of course, if you need to query the database and so on, you cannot cache, because it depends on each request. So having said that, all the Firebase platform is highly scalable. Okay, so I can tell you from real life project that if you have a heavy load, I mean the platform just spins up some new instances, and the response time are normally very good. So I have never really connected Cloud Function to Firebase hosting apart from trying Code Lab or examples, but because I never had the need to do that, but I've never heard any problem in terms of scalability. Sorry to not be able to answer very precisely for this question.
Okay. I think I just lost internet for a second there, but I got the last part of the question. And of course, it's complex because in many cases, you actually do want to go with running some instances in the cloud anyways, because you might want to, for performance reasons, keep that up for a backend.
I mean, like anything, you will not be able to eat the cake and still have it, So you have to pay for the serverless advantages. Okay, so like I said, sometimes it's you need to change your approach and to use another platform.
All right. Are there any last questions from the audience? I think the general gist in the chat is that people have to run, but I think it's very important that you can always reach out, or you can probably even just post it on GitHub and on Stack Overflow, and then there's a good chance if you have a Firebase question that it would be Renaud who's actually answering it. So
yeah, I'm like a five-star listener. I'm on Stack Overflow watching for five-star Firebase questions. So in particular cloud functions. So yeah, do not hesitate, and contact me also Twitter, etc. Like I said at the bottom of the presentation, you have my all the way to connect. I will be happy to connect with you guys.
Great, Renaud. I think we'll give you a chance to rest your voice and let people get maybe some dinner going. So yeah, as this is a format where we can't give you a massive round of applause, just know that we would have done if you were here in real life. And thank you so much for sharing your insights with us. And hopefully we can welcome you back, at least online, but maybe also in real life one day. So
yeah.
Thank you for your
Thanks
contribution.
Thanks a lot for your kind words. Thanks to all of you for listening to my presentation. Sorry again for having taken 2 hours instead of 1.
No worries.
But
it happens.
Thanks again for your welcome, and I was very happy to do this talk and to share with you. It was a bit difficult because indeed we are not in real life, so I was in front of my screen. But I hope you enjoyed it. I hope you learned, and that's it. Keep
Perfect.
going with Firebase, and also I will be happy to go to Aarhus one time, but
have a standing invitation. I can tell you that we're more than happy to host you when there's an opportunity.
Thanks a lot.
Everybody says thank you in the chat, and said it was an amazing talk, got a lot of insights, and great event, and very nice content, and yes, I think it was a success. So well done. Thank you so much. Thank you everybody for joining, and we'll see you at the next talk.
Have a good evening.
Bye-bye. Thanks
Bye.
again. Have a nice evening.
Bye-bye, everybody. Thank you. Bye-bye.
Bye.
Bye.